Okay, ladies, we are going to begin talking about your immune system and my immune system. How are you guys all doing? Good? Okay, so the way we're going to do this is we're going to talk about this in two parts, okay? Today we'll talk about what's called the, I'll show you here actually. It's called the non-specific line of defense. So today we'll talk about these two, and then tomorrow we'll talk about the specific line of defense. The stuff in orange on the left is basically what you're born with, and you can't really change it. Okay. Stuff on the right is what your immune system learns over time. Okay. So that's how we're going to divide this. We're going to talk about how your immune system, what you're kind of stuck with, which is the innate part, and then how your immune system learns. Can you give me an example of your immune system learning something that, first you got sick and then you learned and then now you're like, if you get it again, you should be okay? Yeah, chickenpox is a good example, right? You learn, if you ever had the chickenpox got the upper hand, you got sick. How many of you ever had the chickenpox naturally? Did you? Was it fun? No? You want it again? What? No? Okay. So, now the idea you get the chickenpox, and should you get it again? No. You might get, later on in life, something called shingles, which is basically the virus coming back, but that's not really the same thing. So we'll talk about how your immune system learns tomorrow. Today we'll talk about the innate line of defense, which is basically divided into two parts, okay? Now, as we go through this, one thing I'll tell you about the immune system, I don't know if any of you want to get into immunology, which is the study of the immune system. To me, the immune system is quite mysterious, okay? And I always tell people, I have an aunt who, at the age of 63 or 64, develops a walnut allergy. And she's Italian. Now, I don't know about you guys know this, but Italians put walnuts in a lot of things. So imagine going through your whole life eating something, and then in your 60s, you become allergic to it. That's weird. That's very mysterious. It's something that you would not expect. So we'll talk about a little bit of the randomness and the mystery of the immune system as we go through this. So the immune system is divided into three layers. The first two layers, I said you're kind of just stuck with it. This is it. It's not really going to change. The first layer is quite easy to understand, and we're not really going to spend much time on it. First layer is basically what prevents things from getting into your body. So if something's going to make you sick, it has to get into your body. That's why it's important if you get a cut, what do you do? What do you do if you get a cut? Roll around in the dirt? No, what do you do? Wow, none of you took first aid, eh? You're supposed to clean the wound, disinfect it. I remember things change, right? When I was taught first aid, or in high school, they would say, if you get caught, let the wound breathe. Let it breathe, they would say. Which is really, the thing about it, is stupid. Because when you have a gash, right? Look at your first line of defense up here. Your first line of defense includes your skin. So your skin protects you from things getting in, right? By the way, what do you call things that want to get in and cause disease? What do you call those things? It starts with a P. Starts with a P. Anybody? They're called pathogens. Okay, so a pathogen is a disease-causing organism. So what's wrong with the idea of getting a cut and letting the wound breathe? In other words, don't cover it. What's wrong with that? What's wrong with that idea? Anneke, what's wrong with that idea? Skin's open, right? There's a barrier that's breached now, right? So the idea is that you are exposed to so many organisms. Not all of them cause disease. In fact, when you think about bacteria, only a small percentage of bacteria cause disease. Most bacteria is actually good for you. But the thing is, when you open up your skin, there are so many things on you, there's so many things around you that you're giving them a chance to get into your body, which is just not probably the smartest thing to do. Okay, so your first line of defense includes the skin. It includes things like mucus that you secrete. These are basically things that will prevent organisms from getting into your body. So the mucus could trap it, and then you can like blow it out of your nose. Or technically, if something gets into your stomach, it's still really not in your body because your stomach has acid that could kill it. So when I mean gets in your body, I mean it actually like gets into under your skin, gets into your bloodstream. Okay. Technically, if it's still in your stomach, it's not really in your body because you could vomit it out. Your stomach, the contents of your stomach are really not still in your body. They haven't really been absorbed. So the first line of defense is just these protective layers. It could be your skin, it could be chemicals that prevent things from getting in. The second line of defense includes cells. Okay. What are the names of cells that protect you in the immune system? What do we call them? What's that? Not antibodies. We'll talk about that tomorrow. What do we call cells that protect you in your immune system? Yeah, I know. What do we normally call them? There's a non-technical term. It's right up there. White blood cells. So you've heard of red blood cells? They carry what? Oxygen? Okay, and then you have white blood cells that protect you. But what's the actual technical term for a white blood cell? Is that? Lymphocytes. These ones? No. Well, okay. So the technical term for a white blood cell is a leukocyte. Okay? And a lymphocyte is a leukocyte that lives in your lymphatic system, which we'll talk about. The lymphatic system is a system that is kind of like your circulatory system, but it's not. And we'll talk about that one tomorrow. So a leukocyte is basically a white blood cell. Okay? So let's talk about the second line of defense. This is a line that will come into play if the first line is breached. So if we get past the first line. Okay? So it includes cells, white blood cells that can swallow other cells. So, for example, this is a macrophage, and it's sitting. Now, what does macro mean? Macro versus micro. What does macro mean? Charlotte? Big. So macrophages are white blood cells that could swallow up other cells. So here you're seeing a macrophage swallowing up three cancerous cells. So your immune system does actually protect you against things like cancer. I know sometimes it fails and sometimes it turns on you. We'll talk about how it could turn on you. I actually should mention this. I was watching this lecture on the immune system. This guy had an analogy of your immune system, which to me is kind of a cool analogy. He said, your immune system is like a pit bull. Now, do you guys know what a pit bull is? Do you know that they're banned in Ontario? Why are they banned? They're aggressive, okay. So his analogy is that, on the one hand, a pit bull could be very loyal and very protective, which is what you want your immune system to be. On the other hand, it could be very dangerous. And what he meant by that is dangerous to yourself. Kind of overreacting. And we'll talk about that, not today, maybe tomorrow or the day after, when your immune system goes wrong. So normally it protects you. And here you're seeing a slide of a macrophage swallowing up another cell that's gone rogue. It's doing something inappropriate. So your second line defense includes a bunch of cells that will target things they're behaving inappropriately or they shouldn't be there. And that includes other cells like natural killer cells, which to me has a really cool name. The difference between these two cells is the first one will swallow something up. The second one will use chemicals to drill holes in the membranes of invaders. So just the way they attack are different, but they're both part of your second line of defense. So if we look at the second line of defense on the left, here are some of the things that you can see. So the second line will include some chemicals. Okay. By the way, this chart summarizes the first and second line and the third line. So on the left, you have what you're born with. That's what's innate. That's just genetically determined. So you can see the skin, the lining of the digestive system, mucus. Mucus is listed there, right? That's right. Then you have their second line of defense, which includes certain chemicals. And then on the right is, you were talking about antibodies. We'll talk about how that works. Okay, so the second line also includes chemicals. Now, we've been studying chemicals now for a while, right? We studied chemicals in chapter 7. Like we talked about ADH, AMP, aldosterone. And then we did more chemicals in chapter 8. We talked about like hormones, right? And then in chapter 9, we talked about more chemicals. We talked about neurotransmitters, right? Like GABA and epinephrine, which could also be a hormone. So chapter 10, we talked about some more chemicals. So lots of chemicals that we've been talking about in this unit. So here are chemicals, like basically a cytokine is, and you can see it's actually here. So the word cytokine includes, you can see that word right here, includes a bunch of, so cytokine is a chemical that comes from your immune system. Okay? And you can see what it includes. It includes interleukins, interferons, and TNFs, which we'll talk about right now. So an interferon is something that interferes with what? The ability of a virus to reproduce. Okay? So these chemicals that your immune system pumps out could inhibit viral reproduction, or they could be what are called interleukins. Now, the interleukins is a whole bunch of them. You don't have to know all of them. I think we're only going to be talking about two of them, number 1 and 2. So, I won't specifically talk about what they do, but here's basically where they come from, and here's one effect. So one effect of an interleukin could be to reset your thermostat. Now that means that, you know how we talked about homeostasis? And by the way, where's your thermostat? In your hypothalamus, in your brain, right? And we talked about if your body warms up too much, it will try to cool you down. So your immune system can actually raise the thermostat. Now that will induce what though? If it raises the thermostat. What does that cause? Starts with an F. Fever. Okay. So the chemical that changes the thermostat is called an interleukin. I think it's interleukin 1 or 2, but I can't really remember off the top of my head. Then we have things called chemokines. Chemokines are chemicals that attract other cells. Now, why would you want to do that? What's that? Well, if you have an infection in a particular spot of your body, you want the white blood cells to know where to go, right? So the cells that are damaged, and you'll see in the animation I'll show you, the cells that are damaged will release chemicals, and that will attract white blood cells. Now, how it works is actually really, really simple. If I was to ask you a question, imagine you guys were blindfolded and we wanted to find Charmy. Okay? and I sprayed Charmy with perfume, lots of perfume, how would you find it? Oh. You would go to where the concentration is what? Highest, right? So you would follow the concentration gradient. You would know that Charmy's over here because as we move towards her, the scent is stronger, right? These chemokines work in the same way. So these cells that release them, where would the highest concentration of the chemokines be? It would be the same as Charmy. It would be on, it's where the cells are, right? Or where Charmy is. So they would basically follow the concentration gradient until they got to the area where there was an infection. And then we have TNFs, or tumor necrosis factors. So these are chemicals that actually attack cancerous cells. These are just different types of chemicals that your immune system will release. And again, they're all called cytokines. Okay. So lots of chemicals in this unit that you're gonna have to remember. Here's some other chemicals. One thing that you'll notice is there's something in the middle between the left and right hand of this slide. What do you notice in the middle? Inflammation. Now, do you know what that means? Inflammation. Can you give me like a symptom? If that body part was inflamed, what would that mean? What would be a symptom? What would be a symptom of inflammation? You ever had inflammation? Okay, what happens if you get whacked on your arm? What happens to the arm? You get hit really hard. What do you see? It gets painful, starts to redden, starts to swell. Yeah. Those are symptoms of inflammation. And you can see inflammation actually connects the left and right side of this. So it's very important. Inflammatory response is a very important thing in your immune system. Okay? So what happens in inflammation is a few things. One is you release a chemical called histamine. Okay? Now, how many of you have ever heard of antihistamines? You ever take them? For what? Dan, what do you take antihistamines for? What's that? Not painkillers, no. You would take them if you have like, let's say you start to get watery eyes or a runny nose because maybe you have allergies to like pollen or something like that. You would take the antihistamines. So because histamines, actually, you'll see they do a few things. One is they make blood vessels leaky. Don't confuse that with a ruptured blood vessel. If you have a ruptured blood vessel and it's starting to bleed out, what do you want to do with that blood vessel? You want to seal it, right? You want to clot it. This is different. These are capillaries. You're not going to die if a capillary is leaky. You'll die if a vein or an artery is leaky, depending on the vein. But capillaries, we talked about this in grade 10. Capillaries are very thin, right? And capillaries are so thin that things can diffuse in and out. So why would we want to make capillaries more leaky so more things can move in and out? What would be the point of that? Why would we want to do that? Okay, think about that. When we get to the animation, maybe you'll see why we need to do this. The inflammatory response also promotes clotting response, which means the blood will clot so that you won't continue to bleed out. Okay? Your inflammatory response will also attract white blood cells or leukocytes. Here is a summary of what happens in the inflammatory response. So you get cells are damaged, and you can see what happens. So this is your inflammatory response. You can see that some blood vessels will dilate. Why would you want to send more blood flow to an infected area? This is different. Again, if a blood vessel is damaged, you don't want to send more blood flow to that blood vessel. You want to actually send less blood. Okay. So, but if you have an infected area and the blood vessels aren't damaged, why would you want to send more blood to the area? Right, because you're sending more white blood cells to that area. The white blood cells are going to be the ones that fight the pathogens. So you got to think of this as an army, right? Your immune system, think of it as an army, and we want to move the army in certain areas. So if you are like a country and you're being invaded in the south, where would you want to send most of your army? To the north? No, you want to send them south. So the reason why you send more blood flow to the infected area is because you can send more white blood cells there. So this is what will happen. These are the symptoms. It'll start to feel warmer. It'll start to feel red. It will bring in your leukocytes that swallow things up. It'll also bring in antibodies, but we'll talk about that tomorrow, okay? The inflammatory response we talked about makes the capillaries more leaky. In other words, they're more permeable. Things can move in and out more easily. Again, you'll notice the antibodies are there because the antibodies are something that are generated in the third line, but we won't talk about those today. So some of the symptoms will be swelling. If things can leak out of capillaries, that means they'll move into the surrounding tissue, and that area will swell up. Because if it accumulates fluid, it'll start to swell in size. You might also experience some significant pain. The inflammatory response also releases interleukin-1, IL-1. That's the one, I couldn't remember if it was 1 or 2, raises your temperature. Why would you want to raise your temperature, though, in an immune response scenario? What's the point of that? There's got to be a point to it because it's a normal response. What are we trying to do? Like, what's the point of raising your temperature? Sounds kind of silly. Because with little ones, if we really worry about their temperature going up, even though it's normal, right? The fever response is normal. Why are we always so concerned about babies and having a high temperature? In that scenario, it's because if the temperature is too high, it could cause what? Yeah, but before we get to that point, you're going to start to see symptoms like, before you get to brain damage, that's really extreme. You're going to start to see maybe seizures. Because if you remember, the temperature changes the proteins in your neurons, and what it does is it lowers the resting state. So the resting state and the threshold get closer, and they become more excitable. So you can have seizures, right? But that's if the temperature goes too high. Normally, it's a good thing to increase your temperature. And if you keep your temperature lower, you'll be sicker a little bit longer. But for babies, it's better to be sicker a little bit longer than to have brain damage, right? But what's going on with fever here? Why do we even do this? Raising the body temperature. So yeah, it'll speed up our body chemistry, and at the same time, I suspect it will make life more uncomfortable for the invaders who aren't used to that high temperature. Because we're used to 37 degrees. We can even push it to 38, 39, maybe even 40. But the invaders, they're not used to that. They're not used to that temperature. And we know organisms are evolved to certain temperatures, so I suspect it's for that reason. Okay, so here's the just information about fever, which we just talked about. Okay. There is another system that actually works with your immune system. It's called the complement system, but I'll let you guys read up about it. I'm not going to spend too much time on it. Okay, but just to let you know, if you do come across it, it's a system that actually helps with your immune system. Here's just some pictures of your leukocytes in action. So here you can see a leukocyte swallowing an invader. Here's a question: how does it know it's an invader? How does it know that? How does your immune system know what's normal and what's not normal? Because it has to make that decision. Because if it's going to attack, it better attack the cells that are not supposed to be there. It makes a mistake. Yeah, very good. And we'll talk about that. So she asked, like, when it turns against you, does that mean it screws up? I mean, exactly. This process does not work well. Because it's supposed to know, okay, this is not supposed to be here. Let's attack it. But in type 1 diabetes, your immune system attacks your beta cells. It's not supposed to do that. It's supposed to have known that that's normal. Leave it alone. What happens? How does it recognize what's normal and what's not normal? So actually, that process actually takes a little bit of time. Actually has to learn that. Actually, it has to learn what's normal and what's not normal. And there are things on the surface of cells, which we'll talk about tomorrow, that your immune system recognizes and sees. So the analogy I always give is kind of like a uniform, right? Like, how does an administrator who doesn't know you know if you belong at a school? What do they look at? The uniform, right? So, and that's on the outside, because if the uniform was on the inside, you wouldn't be able to see it. So your immune system, and we'll talk about this more tomorrow, does the same thing. It looks on the outside of an invader, or a cell, and there are certain things on the outside, like proteins, markers, and that will tell the immune system, yeah, that's normal. No, that doesn't look right. And it's kind of like the uniform. And what's really interesting is that some pathogens have the ability to, because if I just told you that, you'd be like, oh, I know how to get into St. Joe's really easily then. Let's go get a uniform off somebody, put it on, and who's going to know if I belong, right? And some pathogens actually have the ability to change the uniform. Like the malarial parasite can do that. So it makes it hard for your immune system to learn, well, that's not normal because they're constantly changing their appearance. So some parasites are really, really tricky. But that's the idea. It has to look on the outside of the cell to say, that doesn't look right. So there are these features. And that's the same thing when you have like a transplant. Like if I give you like part of my liver, right? Your body can look at the cells and look at the surface of the cells and distinguish whether or not they look normal. And if we're compatible, that means they'll look normal. But if we're not compatible, your immune system is like, this doesn't look right, and it will attack it. So today, and this is where I'm going to end, today we've just been talking about what's called innate immunity, and this is like what you're just born with. You cannot change it. So these are things that if you were to get exposed to a virus, right? Imagine you got exposed to a virus for the first time. And this is a virus that you have never, ever seen before. Okay? You've never seen it. Your immune system has never seen it before. And you don't get sick. But Iris does. Imagine Charlotte and Iris are both exposed to this virus. Charlotte doesn't get sick, but Iris does. Or did I say the other way around? Okay, so Charlotte doesn't get sick, Iris does. They've both never seen the virus. So it's not like, well, maybe Charlotte was vaccinated. Maybe she saw it before. No. Never seen it before. It's a new virus. A new virus, by the way, is called a novel virus. Why did Charlotte not get it? What's the difference? So that's innate immunity. There's something different about Charlotte's genetics that prevented her from getting that virus. It's not because she learned to deal with the virus. There's something different about her. And the idea is really simple. Like, you guys know how a virus gets into a cell? A virus has to attach itself to the surface of a cell. And I've used this analogy a million times, but you gotta think of the virus like a key, and Charlotte's cells are like the lock. If the virus can fit into the lock, they'll open it up and get in. Now, if Iris's genetics are slightly different than Charlotte's, so the cells that are making locks in Iris make locks that the virus can fit into, those viruses can get into Iris's cells, and she can get sick. But if Charlotte has a mutation in the genes that make the lock, right? She's born with that mutation, and her lock is different. When the virus tries to get into her cells, guess what? Doesn't happen. So there are. Did you guys take grade 11 with me? You guys, we talked about this with the unit on evolution. Like, for example, with you guys know how HIV works? What happens in HIV? What happens in HIV? The virus attacks what cells? Actually, it attacks your white blood cells. But people who have a mutation in a gene called CCR5, so this gene, if you have a mutation in this gene, have resistance to HIV. The virus can't get into the cell well. Same thing with malaria. Remember the idea with malaria and sickle cell anemia? If you have a gene that gives you sickle cell and you have one copy of it, the parasite can't get into the red blood cells. Those are things you're born with. Okay? How many of you seen the movie Contagion? You haven't seen Contagion? Oh, that's a scary movie. So in Contagion, this is a really scary outbreak of a virus that kills pretty quickly. And a lot of people who are getting it die. But Matt Damon, who's the star of the show, gets exposed, but doesn't die. And the reason why he doesn't die is because there's something different about him genetically. Right? It's not because you've seen the virus before, because it's a new virus. You guys have heard of the Black Death? The plague, Middle Ages, that killed 1/3 of Europe. Why did people survive that? Because that was new. That was a bacterium. But why didn't everyone die? Because because of that genetic variability. Not everyone is the same. If you get something and your immune system learns, that's what tomorrow's lesson will be about. That's acquired immunity. That's your third line. Okay? But we'll talk about that tomorrow. So what I'm going to do right now is I'm going to end here, and I'll show you an animation that goes over the first line of defense. Second line of defense. Actually goes over both. Okay, ladies, so that is it for part 1.